What if I told you we've found Earth's evil twin, a planet so similar to ours that scientists once called it the most Earth-like world ever discovered? Yet this cosmic doppelganger might be one of the most horrifying places in the universe. Meet Kepler 438b, a world that seems perfect on paper. It's just 12% larger than Earth, sits in the habitable zone where liquid water could exist, and maintains temperatures similar to our own planet. When astronomers discovered it in 2015, headlines proclaimed it as our best bet for finding alien life. But there's a sinister twist to this story, one that reveals just how lucky we are to live on Earth. This isn't a tale of distant alien worlds that have nothing to do with us. It's a story about radiation storms so powerful they could strip away entire atmospheres, about the fragile balance that makes life possible, and about how quickly a paradise can transform into hell. Today, we're traveling 470 light-years to explore what might be the most dangerous Earth-like planet ever found, and what its existence teaches us about the knife-edge conditions that make our own world habitable. What do you think makes Earth truly special compared to other potentially habitable worlds? Share your thoughts in the comments. I'm genuinely curious about your perspective. To understand why Kepler 438b is so significant and so terrifying, we need to understand humanity's quest to find another Earth. For centuries, we wondered if we were alone in the universe, but only in recent decades have we developed the technology to search for worlds beyond our solar system. The Kepler Space Telescope, launched in 2009, revolutionized this search. Named after Johannes Kepler, the German astronomer who first described planetary motion, this remarkable instrument could detect the tiny dimming of starlight that occurs when a planet passes in front of its host star, a method called the transit technique. Think of it like watching a moth fly in front of a streetlight. The moth is incredibly small compared to the light source, but you can still detect its shadow. Kepler could measure brightness changes as small as 0.01%, equivalent to detecting a flea crawling across a car's headlight from several kilometers away. By 2015, Kepler had discovered thousands of exoplanets, but most were giants, gas worlds bigger than Jupiter or scorched rocks closer to their stars than Mercury is to the Sun. Scientists were searching for something specific. Planets in the habitable zone or Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist. The challenge is immense. In our galaxy alone, there are roughly 100 billion stars, and astronomers estimate at least 100 billion planets. Finding potentially habitable worlds among this cosmic haystack requires incredible precision and patience. When Kepler 438b was discovered, it seemed to check every box. Its host star, Kepler 438, is a red dwarf, smaller and cooler than our Sun, but stable enough to support life for billions of years. Red dwarfs make up about 75% of all stars in our galaxy and burn their nuclear fuel so slowly they could shine for trillions of years. The planet orbits its star once every 35 days, much closer than Earth orbits the Sun. But because Kepler 438 is so much dimmer and cooler, this close orbit places the planet right in the habitable zone. Scientists calculated that Kepler 438b receives only 40% more starlight than Earth receives from the Sun. Not enough to boil away oceans, but enough to keep them from freezing. The initial excitement about Kepler 438b was extraordinary. Dr. Guillermo Torres of the Harvard-Smithsonian Center for Astrophysics called it the most Earth-like planet discovered to date. With an Earth similarity index of 0.88, where 1.0 would be an exact Earth twin, it seemed like the holy grail of exoplanet hunting. But within months of its discovery, astronomers at the University of Warwick made a chilling discovery that transformed our understanding of this world. Dr. David Armstrong and his team were studying the behavior of Kepler 438 when they detected something unprecedented: superflares. These aren't ordinary solar flares like the ones our Sun produces. Kepler 438 unleashes superflares approximately 10 times more powerful than the strongest flare ever recorded from our Sun. To put this in perspective, each superflare releases energy equivalent to 100 billion megatons of TNT. That's roughly 2,000 times more powerful than the largest nuclear weapon ever detonated. Unlike Earth's relatively quiet Sun, Kepler 438 emits strong flares every few hundred days, each one stronger than the most powerful recorded flare on the Sun, Armstrong explained in his groundbreaking 2015 study. But the flares themselves aren't the real problem. The true danger comes from what likely accompanies them: coronal mass ejections, or CMEs. When our Sun produces a strong flare, it often hurls massive amounts of plasma and magnetic field into space. Earth's magnetic field deflects most of these particles, creating beautiful auroras when some slip through to our upper atmosphere. Kepler 438b has no such protection. Dr. Chloe Pugh, a co-author of the Warwick study, explained the devastating scenario. Large coronal mass ejections have the potential to strip away any atmosphere that a close-in planet like Kepler 438b might have, rendering it uninhabitable. The process would be apocalyptic. Each superflare would launch billions of tons of high-energy particles toward the planet. Without a strong magnetic field to deflect them, these particles would slam into the upper atmosphere, heating it to thousands of degrees and literally blowing it away into space. Over millions of years, this cosmic sandblasting would strip away any atmosphere the planet once had, leaving behind a barren, airless world subjected to the full fury of its violent star. The surface would be bombarded with deadly ultraviolet and X-ray radiation, along with charged particles that would sterilize any organic molecules. Recent computer models suggest that Kepler 438b could lose its entire atmosphere in just a few million years under this constant bombardment, a blink of an eye in cosmic terms. What might have started as a warm, wet world could have become a radiation-blasted wasteland, more similar to Mercury than to Earth. The story of Kepler 438b raises profound questions about the nature of habitability and the incredible fortune that allowed life to flourish on Earth. It demonstrates that being in the habitable zone isn't enough. A planet needs protective systems that we're only beginning to understand. Some scientists argue that Kepler 438b might still retain some atmosphere if it possesses an unusually strong magnetic field. Magnetic fields are generated by the motion of molten metal in a planet's core, and we don't yet know if Kepler 438b has such a dynamo. Dr. Armstrong noted, "If the planet has a magnetic field like Earth, it may be shielded from some of the effects." However, even optimistic scenarios paint a grim picture. The superflares are so powerful that they might overwhelm even a strong magnetic field. Earth's magnetic field protects us from our sun's relatively gentle solar wind, but Kepler 438b faces a constant hurricane of high-energy particles that would challenge even the strongest planetary defenses. This discovery has forced astronomers to reconsider what makes a planet truly habitable. The traditional habitable zone concept, based solely on distance from a star, is now recognized as overly simplistic. Scientists now speak of the habitable zone complex, which includes factors like stellar activity, planetary magnetic fields, atmospheric composition, and orbital dynamics. The case of Kepler 438b also highlights a troubling possibility. Many potentially habitable planets orbiting red dwarf stars might face similar fates. Red dwarfs are attractive targets for habitability studies because they're so common and long-lived, but they're also prone to violent flaring, especially when young. Dr. Aomawa Shields of UC Irvine, who studies exoplanet atmospheres, points out another cruel irony. Planets around red dwarfs need to orbit very close to stay warm, but that puts them right in the danger zone for stellar radiation. Some researchers are exploring whether life might find ways to survive even in these hostile conditions. Perhaps organisms could evolve thick radiation-resistant shells, or life might persist in subsurface oceans protected from surface radiation. But these would represent completely alien forms of life, bearing no resemblance to anything on Earth. The broader implications are sobering for our search for extraterrestrial life. If most red dwarf planets face similar challenges, it significantly reduces the number of worlds where Earth-like life could evolve. This might help explain the Fermi paradox, why we haven't encountered obvious signs of intelligent life despite the vast number of potentially habitable worlds. The tale of Kepler 438b serves as both a cautionary story and a reminder of Earth's extraordinary good fortune. What appeared to be our planet's twin turned out to be its opposite. A world where the very star that should nurture life instead destroys any chance for it to emerge. This discovery fundamentally changed how we think about planetary habitability. It's not enough for a world to be the right size, at the right distance, with the right temperature. A potentially habitable planet needs a quiet, stable star, a protective magnetic field, and probably a dozen other factors we haven't even considered yet. Perhaps most remarkably, Kepler 438b shows us just how special Earth really is. Our sun is remarkably stable for a star. It hasn't produced a superflare in recorded history and likely never will. Our magnetic field, generated by our planet's molten core, has protected our atmosphere for billions of years. Our position in the galaxy, our moon's stabilizing influence, our plate tectonics, All of these factors contribute to making Earth not just habitable, but continuously habitable for eons. The search for life beyond Earth continues, but Kepler 438b has taught us that true Earth twins might be far rarer than we once hoped. In a universe full of radiation-blasted wastelands masquerading as paradise, Earth stands out as an oasis of stability in a hostile cosmos. But here's the question that keeps astronomers awake at night. If planets like Kepler 438b represent the norm rather than the exception, what does that mean for the prevalence of life in the universe? Are we incredibly lucky to exist on one of the rare worlds where life can flourish? Or are we missing something fundamental about how life adapts to extreme conditions? The next generation of telescopes, including the James Webb Space Telescope, will help us peer deeper into the atmospheres of distant worlds and search for signs of life under conditions we never imagined possible. Subscribe to GeoCurious for more explorations of the strange and wonderful cosmos around us, and let me know what mysteries of space you'd like us to investigate next.